Okay, I'm back for the next episode of the Fractal Cosmos. This is a very interesting equation. It's very simple. You may read it in the treatise there and find it much more difficult than it seems, but it's really quite simple. What it's saying is that when our universe was first formed, it had only one standing wave pattern in it. The substrate collapsed and it began to vibrate due to the balance between the gravitational energy pulling those substrate atoms in and then the energy of heat or pressure pushing it out. And this vibrates. We can call it a ringing phenomenon, but it starts with one massive standing wave pattern in this substrate. However, over time, it's hard to get your wits around this, but over time this energy becomes distributed over many atoms, and the more time that passes, the more atoms this energy becomes distributed over, until you have 10 to the 88th atoms in our universe now. Now these atoms are extremely small. They have a radius of R0. If you compare the energy with the initial energy, you'll come up with R0 cubed divided by little r0 cubed. This is for the zero universe. So energy total of the universe divided by the energy of one nucleon is a cubic, is this ratio cubed. However, remember these little particles actually have shells, and each shell contains the same amount of energy as a core. So the number of these shells is R0 over big R0 over little r0. That's how many shells in a single atom. So we have to multiply this bottom energy in a nucleon. That's just the core of the nucleon. We have to multiply it by this number. So we come up with the number of nucleons in the universe, which would be E0 divided by the total energy of a nucleon, is equal to R0, big R0 over little r0 squared. So it's the radius of the universe, approximately 10 to the 26 meters, divided by the radius of an atom, approximately 10 to the minus 16. So that could give you 10 to the 42nd squared, 10 to the 84th, 10 to the 88th. We're in the ballpark for the number of atoms in the universe just by adding up the energy in the atom and comparing it with the initial energy of the universe, assuming that there's this maximum pressure of 2p0 controlling the energy in the core of these atoms, and also the maximum pressure that can be reached in that substrate. So there you have a simple equation giving you the number of atoms in the universe based on first principles. That's interesting enough, but then consider the number of atoms in the next level universe, the next level. I don't have to tell you how that goes up exponentially. So that's all on that topic. Next we'll cover some of the phenomena relating to motion of atoms.